Okay, the first order of business is to come over to the fridge and get out the solder paste. This is solder paste. It comes in these syringes, and sometimes you have to let it warm up to room temperature before you get it to flow very well. So I'm going to bring this over here to the pick and place machine and show you how to attach it and how to turn the pick and place machine on. So the solder paste dispenser goes in this little bracket here, and let me put this down, do this. So there's two parts to this. One is to put this little thing in the plunger. Involves pushing the O-ring down to make a good seal, and then twisting this so that it locks around the edge of the syringe, like so. And then getting this thing to go down. Which is not the easiest thing to do sometimes. Okay, so now the syringe of solder paste is in the holder. You come over here, you push this button, and that turns the compressed air feed on. And then this button up here turns on the solder paste dispenser. You can see that this little dial right here sets the pressure, the air pressure that's used in the solder paste dispenser. You probably shouldn't need to muck with that at all, but if you do need to muck with it, you basically pull this out a little bit, turn it to change where the dial is, and then push it back in. So I'm going to check the level of the solder paste dispenser needle. You'd like the solder paste dispenser needle to be slightly lower than the vacuum tweezer. Right now it looks like it's probably a little too high up. So I'm going to adjust that. Okay, that actually looks pretty reasonable. Okay, so I'm going to let this warm up for a little while, maybe like 15 minutes, and we'll come back and see if it'll feed any solder paste out. Sometimes the needle, especially with very fine gauge needles, the needle will get gunked up and will have to be replaced. So we'll see if that turns out to be the case. Okay, we're back. This foot pedal down here dispenses the solder paste. And what I'm going to do now is see if the solder paste is actually going to flow by seeing if it comes out of the end of the needle. You can see it, that little blob of solder paste there is flowing, so that's good. Okay, I'm going to set up the camera and put a board in, and we'll paste the board. Okay, now this board is small enough that I think it's going to be beneficial to, or necessary actually, to put it on a kind of a carrier board, otherwise it won't fit in this little clamp. So put a carrier board in, and we put the board on top of it. Now we're going to go around to each pad and apply a little tiny bit of solder paste. Let's see if I can get this closer. Get this close as high as I'll be able to get. It's easy to apply too much solder paste, especially to the tiny pads. For this board, I'm going to put all the components on at the same time. Occasionally, especially when I'm working with QFN packages, I will make a couple of passes, one for the QFNs and the parts with very, very fine pad pitches, and one for all the rest of them. That way you don't have all the components around the QFNs in case you need to break some bridges with solder wick. But for this one, I'm going to do all of them at the same time. And the final thing is to attach the USB connector. Okay, it's a little hard to see. I definitely can't zoom in very much more. Precisely how much solder paste I applied, but it's like a little tiny blob in the center of each pad. Yeah. Okay, now we're going to go over and get the components. Okay, the first thing I'm going to put down, in this case, are the integrated circuits. It's the regulator and the op amp. And what I always do is just get the components out just before I am ready to apply them. So I cut tape, peel off just enough of the tape to expose one of the components, dump it out, that's the regulator, here's the op amp. In this case, the two parts are distinguishable by their package, so no chance of confusing them. But I generally, especially for parts that are in the same package and you really can't distinguish them easily, I do those quite separately in time. Okay, so what we do is we turn these over with tweezers, get them in the right orientation. And drop them on the pad. Sometimes you have to nudge them a little bit. Get them aligned. Getting them on the pads is important, but getting them precisely aligned is something that happens with surface tension once the solder reflows. Okay, so at this point I'm going to rotate this board a little bit because I find it's easier to place the two terminal components when the board's oriented this way. Most of the parts are horizontal. So this is going to be my 1K current limiting resistor for my LED. Goes there. Next will come the green LED. Now, the orientation of the LED obviously matters. And there's two little green dots that show where the little bar goes. In this case it has to be oriented toward the right. Like so. There comes the 90.9 K resistor. Goes right here in the lower left-hand corner. Next comes the two 10 meg resistors. Which go in the next two positions up. Next come the two 158K resistors in the voltage divider. That sets the mid-rail reference. come the 2.1 microfarad caps. This one up here is the one that sets the RC time constant for the oscillator, and this one is the one that is the bypass, local bypass cap for the op amp. Okay, I'm going to rotate this back around. To put the 2 10 microfarad caps on. These are the input and output capacitances for the regulator. Okay, all the components are in place. Now we'll go on to the next phase. Okay, the next phase is to set up the reflow oven. So this is our reflow oven, and the most important thing to do to begin with is to adjust the spacing between these racks to be appropriate for your printed circuit board. Again, because this board is so small, it's going to be necessary to put this on support this on a carrier board. So I've already adjusted this rack to be the width of the carrier board. But it's important to do this before the oven preheats. If you have to do it when the oven is hot, you'll burn yourself. So what you do is you loosen these thumb screws and slide these back and forth to be the appropriate width. Okay, once you've got that set up, you shut the drawer. And now to turn the oven on, the oven actually stays on all the time. In fact, you should not power it off. To actually start the oven up, what you do is you press these 2 buttons here on the end at the same time. That wakes it up. Then you press the start button. You press start for program 4, and the oven is preheating. The oven should heat up to 150 degrees, preheat to 150 degrees Celsius. If it preheats to a higher temperature than 150 degrees Celsius, somebody has probably programmed in a different temperature profile, one for probably lead-free solder. So let's see if this looks like it's stabilizing at 150. That's good. I'm going to let that stabilize. This diagram up here on the wall is the recommended reflow temperature profile for the solder paste that we're using. It's a 63% tin, 37% lead alloy. Maybe it's the other way around. What it does is it will basically preheat the board to 150 degrees Celsius to make sure everything is kind of up to a temperature that's not too far below the reflow temperature of the solder, but so this like preheats all the copper planes and everything. And then after 120 seconds or 2 minutes of the board being at that temperature, it ramps up very quickly to 230. Solder reflows, and then it cools down very quickly after 90 seconds. So sometimes people will reprogram a different profile in here for a different solder, so you may have to, solder paste, you may have to actually change it back to this profile. Anyway, that's something which, if you need to do the manual, is helpful. It's usually floating around here, not too far away from the oven. I'm going to wait for this thing to stabilize. It's always fun waiting for this to stabilize. 2 more degrees. There's it one. Almost there. Oh, okay. Now it's time to insert the PCB. Okay, so we open the drawer. Carefully get the PCB, put it on there, and shut the drawer. Pretty important to open the drawer when this 230 degree phase is over with, so the boards can cool down. So just be aware of that as you're baking your boards. It'll beep at you when there's a 5-second warning. Comes the beep. And there is the board. And hopefully all the components will be nicely soldered down. Inspect it. Okay, now I'd like to transfer the board, which is still pretty hot, to the counter. Some tweezers. Carry your board out. So you should see nice little fillets where the solder kind of has flowed in up the side of the component a little bit and onto the pads. Once you've inspected it and made sure that all the solder joints look good, the next phase is to put the USB Type A connector on, flip it over, and use the regular soldering iron and the wire solder to solder the connector on. And then we'll test it. Okay, so the first thing to do is to put this USB connector through the little board locks, flip it over, now the idea with through-hole soldering, as you probably know, is to heat the work and not the solder. So I like to bring the soldering iron in. Oop. Let's try that again. Pad. Feed the solder in. Until it flows everywhere it needs to go. Those are the 2 board locks. And now there's 4 pins that we need to solder. again, you should see a nice little fillet extending from the pad up the pin, going through the hole, and it should be nice and shiny. Like so. You need to let it cool down for a few seconds before you kind of see some shiny, kind of gooey flux residue on the bottom of the board there. And you can kind of clean that off with either some isopropyl alcohol or some ethanol, or these handy flux remover pens in the EE Proto Room here. And you can basically just kind of paint the area where the flux residue is with this pen. This pen contains kind of some high solvency alcohols. I'm not sure precisely what alcohols it contains, but from the smell of it, it's probably alcohol. Especially the wire solder has rosin flux in it, and that's quite sticky and gooey. So once you've cleaned that flux residue off, we are all done with soldering. Voila. Okay, now for the moment of truth. It works. How about that?